You think you want to know why gravity works? You don't? Not really. What you want is a story that feels like understanding, a chain of words that lets you nod and say, "Ah, yes, now I get it." But here's the uncomfortable truth. The question itself is broken. It's asking for something that doesn't exist. And if you're willing to sit with that discomfort, if you're willing to let go of what you think you know, then maybe, just maybe, you'll glimpse something far stranger and more beautiful than any answer could ever be. You've felt gravity your entire life. Right now, as you hear these words, it's pressing you down into whatever surface holds you. Your feet on the floor, your body in a chair. Every breath you take is pulled earthward. You don't think about it because it's always been there, this invisible hand that keeps you tethered to the ground. Drop something, anything, a pen, a cup, your phone, and it falls. Every single time. No exceptions. You've seen this happen 10,000 times, maybe 100,000. And somewhere along the way, you stopped being amazed by it. You started calling it normal. But what if I told you that normal is the strangest thing in the universe? Watch a child drop a toy for the first time. Watch their eyes widen as it accelerates toward the floor. They don't know the word gravity yet. They don't have an explanation. All they have is the raw phenomena, the pure experience of watching something fall. And in that moment, they're closer to the truth than you are, because they haven't yet made the mistake of thinking they understand it. You were taught an answer in school. Maybe you remember it. Objects with mass attract each other. The Earth is massive. You're less massive. So the Earth pulls you down. Newton's law of universal gravitation. Every particle attracts every other particle with a force proportional to their masses and inversely proportional to the square of the distance between them. You probably even saw the equation. F equals G times M1 times M2 divided by R squared. Clean, elegant, satisfying. But here's what that equation doesn't tell you. It doesn't tell you why. It tells you how much. It tells you when. It describes the pattern with stunning precision. You can use it to predict the orbit of planets, the trajectory of a baseball, the tides of the ocean. But description isn't explanation. Knowing that objects attract each other doesn't tell you why they attract each other. It just gives a name to the mystery. So you go deeper. You learn about Einstein. You learn that gravity isn't really a force at all. It's the curvature of space-time. Mass bends space around it, and objects follow the curves. The Earth sits in space like a bowling ball on a stretched rubber sheet, creating a depression. And you roll toward it not because something is pulling you, but because the shape of space itself guides your path. This feels better. This feels like progress. Now you're not just describing what happens, you're explaining the mechanism, right? Except you're not. You've just moved the mystery one level deeper. Now the question becomes, why does mass bend space-time? What is it about matter that distorts the geometry of the universe? And if you try to answer that, you'll find yourself reaching for quantum field theory, for the Higgs mechanism, for gravitons that may or may not exist. You'll find yourself building towers of abstraction, each level resting on the one below, each answer creating new questions. And eventually, if you're honest, you'll hit bedrock. You'll reach a place where the only answer is, that's just what the universe does. That's the pattern we observe. That's the rule that seems to hold everywhere we look. And that's where the question why stops working. This bothered people. It bothered Newton himself. He hated that his law of gravitation required action at a distance. The idea that the sun could somehow reach across 93 million miles of empty space and tug on the Earth without touching it. He called it absurd. He said no one with any competence in philosophical matters could believe it. And yet, there it was. The math worked. The predictions were accurate. Reality didn't care whether he found it philosophically satisfying. It bothered Einstein, too. He spent the last decades of his life trying to unify gravity with the other forces, trying to find a deeper pattern, a more fundamental why. He never found it. And today, almost a century after his death, we still haven't found it. Gravity remains stubbornly separate from quantum mechanics. The two most successful theories in physics, general relativity and quantum field theory, are fundamentally incompatible. They each work beautifully in their own domains, but put them together and the math explodes into infinities and nonsense. So where does that leave you? You wanted to know why gravity works, and instead, you've been told that the question itself might be meaningless. That's unsettling. It feels like a dodge, like I'm refusing to answer. But stay with me, because something important is happening here. You're confronting the edge of human knowledge, the boundary where our ability to explain runs out. And that boundary tells you something profound about the nature of understanding itself. Listen to how you think about explanation. When a child asks why the sky is blue, you can tell them about the scattering of light, about how shorter wavelengths bounce off air molecules more than longer wavelengths. That feels like an answer because you've reduced something unfamiliar, the blueness of the sky, to something more familiar, the behavior of light waves. Explanation always works this way. It takes the strange and connects it to the familiar. It says, this thing you don't understand is really just like this other thing you do understand. But what happens when you ask why gravity works? What familiar thing can you compare it to? You can't say gravity is like magnetism because then you'd need to explain why magnetism works. You can't say it's like the strong nuclear force because that just pushes the question back. At some point, you run out of more familiar things. At some point, you hit something that just is, something that can't be reduced any further, because it's part of the bedrock of reality. And gravity might be that bedrock. It might be one of the fundamental patterns that the universe is built from, something that can't be explained in terms of anything simpler, because there is nothing simpler. Asking why gravity works might be like asking why existence exists, or why mathematics is consistent, or why there's something rather than nothing. These aren't questions that have answers. They're questions that reveal the limits of questioning. Feynman understood this. He understood it viscerally. There's a recording of him, an interview from decades ago, where someone asks him to explain why magnets repel each other. And instead of launching into an explanation, he stops. He thinks. And then he says something that sounds almost evasive at first. I can't explain that attraction in terms of anything else that's familiar to you. He goes on. He talks about how explanation works, how it depends on what you already accept as familiar. He points out that if he tried to explain magnetism in terms of forces, the questioner would just ask why those forces work. If he explained it in terms of fields, they'd ask why fields work. No matter what explanation he gave, there would always be another why waiting underneath. And eventually, he says, you just have to accept that this is what the universe does. This is the pattern. This is the rule we've observed. People misunderstand this. They think Feynman has given up, admitting defeat, saying we can't know anything, but that's exactly backward. What he's doing is showing you that knowledge has a different structure than you thought. You imagined it as an infinite tower, each explanation supporting the one above it all the way down. But it's not like that. It's more like a web, where every piece connects to every other piece, and the whole thing floats in something we can't quite name. The patterns we call laws of physics aren't deductions from deeper principles. They're the deepest principles we've found. And maybe, just maybe, they don't come from anything. Maybe they just are. So let me tell you what we actually know about gravity, stripped of the pretense that knowledge means explanation. We know that every piece of matter in the universe affects every other piece, not sometimes, not under special circumstances, always. Right now, your body is being pulled by the moon, by Jupiter, by galaxies, billions of light years away. The effect is tiny, unmeasurably small for distant objects, but it's there. You are gravitationally connected to everything that exists. We know that this influence propagates at the speed of light. If the sun vanished right now, you wouldn't feel it for 8 minutes, not because the information is traveling through some medium, but because space-time itself can only change at that speed. Gravity isn't a thing moving through space. It's a feature of space, and space has a speed limit. We know that mass and energy are equivalent, and both create gravitational effects. This isn't obvious. You'd think only matter would gravitate, but light gravitates too. A beam of light passing near the sun bends, not because it's being pulled by a force, but because the sun's mass warps the space the light travels through. Even pure energy, even things with no mass at all, participate in gravity. We know that time runs differently in gravitational fields. Put two identical clocks in two different places, one on the ground, one on a mountaintop, and the one on the mountaintop will tick faster. Not by much, fractions of a second over a lifetime, but measurably, undeniably faster. Gravity doesn't just pull on objects, it pulls on time itself. The deeper you are in a gravitational well, the slower time flows. And this isn't some theoretical abstraction. GPS satellites have to account for this. If they didn't, if they assumed time was the same everywhere, your navigation would drift miles off course within hours. We know that gravity can create horizons, boundaries in space-time, beyond which nothing, not even light, can escape. Black holes are real. We've photographed them. We've watched stars orbit them. And they prove something extraordinary, that gravity can be so intense it breaks space-time itself, creating regions where our equations fail, where time and space trade places, where the normal rules dissolve into something we can't fully describe. All of this is confirmed, tested, measured. We've dropped objects in vacuum chambers, timed their fall with atomic precision. We've watched binary pulsars spiral toward each other, losing energy to gravitational waves exactly as Einstein predicted. We've detected those waves directly, felt the ripples of colliding black holes wash over our planet, stretching and squeezing space by amounts smaller than a proton's width. The theory works. The predictions come true. The universe follows the pattern, but none of that tells you why. And here's what I need you to understand. That's okay. The absence of a deeper why doesn't make gravity less real or less knowable. or less magnificent. What we have is something different from explanation. We have description, precise, mathematical, predictive description. We have the ability to say exactly what will happen in any gravitational situation, to calculate the orbit of a spacecraft or the merger of galaxies. We have a web of relationships connecting gravity to time, to space, to energy, to mass, showing how they all interweave and influence each other. What we don't have is a story that makes it feel simple. We don't have a reduction to something more fundamental, and maybe we never will. Maybe gravity is fundamental. Maybe it's one of the threads woven into the fabric of reality, and asking why it's there is like asking why reality has fabric at all. You feel cheated by this. You wanted a why, and you got a what. But look closer at what you've received. You've learned that gravity connects you to everything in the cosmos. You've learned that it's not a force applied from outside, but the shape of space-time itself. You've learned that it affects time as much as space, that it can trap light, that it ripples and waves and warps. You've learned that every atom in your body is participating in this cosmic dance, responding to the curvature created by every other atom, every star, every galaxy. You are not separate from gravity. You are made of it. Your existence, the fact that atoms cluster into planets, that planets cluster into solar systems, that stars cluster into galaxies, all of it depends on gravity. Without it, the universe would be a thin, expanding gas, particles drifting apart forever, never condensing into anything interesting. No stars, no planets, no chemistry, no you. So when you ask why gravity works, you're asking why you exist. You're asking why the universe is structured instead of formless, ordered instead of chaotic, capable of creating complexity instead of sliding into maximum entropy. And that question doesn't have an answer because it's asking for a perspective outside of existence itself. It's asking for a view from nowhere. The truth is simpler and stranger than any explanation could be. Gravity works because that's what space-time does when there's mass energy in it. It curves. And objects move along those curves not because something pushes them, not because something pulls them, but because curved paths are the straightest paths available. A planet orbiting a star is moving in a straight line through curved space. It's not being deflected. It's not being held in place. It's just following the geometry. And you, right now, sitting or standing wherever you are, you're not being pulled down. You're trying to move through time in a straight line, but the Earth's mass has curved space-time around it, and your straight line through time is a curved line through space. The floor pushes up against you, preventing you from following the natural geodesic. If the floor vanished, you'd fall, and that falling would feel like floating. You'd be weightless. You'd finally be moving freely through space-time, following the curve that was there all along. This is why astronauts in orbit feel weightless, even though Earth's gravity is almost as strong up there as it is on the ground. They're not beyond gravity. They're surrendering to it completely. They're in free fall, following the curve, and in that state of surrender, gravity disappears from their experience. It's only when something blocks the natural path, a floor, a chair, the surface of a planet, that you feel weight. Weight is resistance to gravity, not gravity itself. So every moment you spend standing on this planet, you're being accelerated upward by the ground beneath your feet. The ground is pushing you away from the natural geodesic, forcing you off the path you would freely follow. And you feel that as weight, as pressure, as the constant sensation of being pulled down. But really, you're being pushed up. Gravity isn't a downward force. It's the curvature of space-time, and standing still in a gravitational field requires constant acceleration. Let that sink in. You think you're sitting still, but you're accelerating upward at 8 meters per second squared every second continuously. The only reason your speed doesn't increase is that you're accelerating through space-time, not through space. You're being pushed along your time axis in a way that exactly compensates for the curvature caused by Earth's mass. And the sensation of that push, that's what you call weight. This is what understanding looks like at the edge, not a simple story that reduces the strange to the familiar, but a reframing so complete that familiar and strange trade places. You thought gravity pulled you down. Now you know the ground pushes you up. You thought falling was motion. Now you know standing is acceleration. You thought you understood the world by standing still in it. Now you know there's no such thing as standing still. And we're back where we started. Why does gravity work? It doesn't work. It's not a mechanism with moving parts that could work or fail. It's the shape of the universe. It's what space-time does. And asking why space-time curves in the presence of mass energy is like asking why circles are round or why triangles have 3 sides. The answer is because that's what those things are. The curvature is what we mean when we say mass energy. They're not 2 separate things with a causal relationship between them. They're 2 ways of describing the same feature of reality. You wanted a why, you wanted a story, you wanted to feel like you grasped it. But understanding isn't grasping, it's letting go. It's releasing the need for everything to reduce to something simpler, something more comfortable. It's accepting that at the bottom of the tower of explanation, there's nothing holding it up. The patterns we observe are the ground floor. They don't rest on anything. They're self-supporting, interlocking, mutually defining, and maybe that's more beautiful than any why could ever be. Maybe a universe that explains itself in terms of something else would be less interesting than a universe that simply is, that follows rules we can discover, but never fully derive from anything deeper. Maybe the brute fact of existence, the sheer fairness of reality, is more profound than any explanation we could construct. You are standing on a planet held together by the curvature of space-time. That planet orbits a star held in shape by the same curvature. That star is one of hundreds of billions in a galaxy held together by gravity, and that galaxy is one of trillions in a universe where every piece pulls on every other piece, where nothing exists in isolation, where the whole thing is connected by this one pervasive, inescapable pattern we call gravity. You didn't choose to be part of this. You don't control it. You can't opt out. But you can notice it. You can look up at the moon and know that it's fallen around you just as you're falling around it. You can feel the ground beneath your feet and know it's accelerating you through space-time. You can watch an apple fall and see not a simple everyday event, but the curvature of the universe made visible. Gravity doesn't have a why. It has a what, a how, a when, a where. And those are enough. They let you navigate the cosmos, predict the motion of planets, build satellites, understand the birth and death of stars. They let you see the connections between things, the deep unity underlying the apparent chaos. They let you know that you are not separate from the universe looking in, but a part of it, looking at itself. And that knowing That raw, direct, unmediated contact with the pattern, that's as close to truth as you're going to get. The rest is just silence.